Hi, my name is Alan Vesna. I'm a senior software engineer at LabKey Software, where I spend a lot of my time writing React code. And so I've got a lot of experience doing it. I've run into all of the potential hurdles, and I'm here to talk about that. So this talk is not a tutorial. The best tutorial out there is the ReactJS tutorial. Just go to their website, take a look at that tutorial. I can't do a better job than it, but what I can do is help guide you and make sure you don't hit any of the major hurdles that I hit. And so what is React? It's pretty straightforward. Straight from the React documentation, it is a JavaScript library for building user interfaces. I like to think of it as a low-level set of code that you can use as Lego bricks. It's not quite a full Lego set. You don't get a big set of instructions, but what you do get are a bunch of little Lego bricks. It's essentially a bucket of Legos, and you get to build your own set. You get to make your own instructions and go from there. So this is what you would be writing normally if you're writing just regular HTML and JavaScript. This is your traditional form, if you will. There's a lot of elements in here. There's a lot of boilerplate code that's repeated, but not quite the same. So you'll see every form row here has a label, it has an input, it has all this information, and it's not quite duplicate code, but it's also a lot of duplicate code, right? So with React, you can reduce that boilerplate. You can build up a form with components that look something more like this, right? So you go from a lot of code that's maybe a little hard to read or takes time to read, and you can boil it down to these higher level components here that do all the same stuff, and in the end will render the exact same DOM, but it's easier to read, easier to manage, easier to debug. And then you can even take these and boil it down even further into a more simple components. Then you have a reusable form, right? So you go from all the way from here to here to here, and it's really great. Especially if you're writing a lot of user interface code, if you have a lot of forms, and especially if they're a lot of them very similar but maybe slightly different. React is a really, really great way to reuse your code and without having to constantly repeat yourself. So one of the key features of React is that you can use all the great modern JavaScript features, and they really do take advantage of it. The way React wants you to write your code, you are best served if you're using the more modern JavaScript features, and I'll get into that. But the notable features are listed here, and I've got a bunch of examples of those. The one thing to note, though, is when you're using these new JavaScript features, they're not supported by the modern browsers, really. Some of them are, some of them aren't. So it does require a build system. So you're going to be using something like Webpack or Rollup or something like that. Typically, it's going to be Webpack. I'm not going to go into the details there. Fortunately, you don't typically have to know all those details. And so let's dive right in. So one of the cool features that the newer versions of JavaScript have is called Destructuring. So way back in the day of, a couple years ago, you would write your code like this, where you have maybe where's the laser pointer? There we go. So you might have, so you have some data here. Maybe this comes from an API response or something like that. Really, this is just me and how cool I am. You would rip out all of the variables you need here over a course of several lines. But now with Destructuring, you can get that data much easier. And so this is nice because you're going to be manipulating objects quite a bit, and you're going to want some sort of syntactic sugar to make that easier to read, less lines of code to read, and just more convenient. Next concept that's very important is the spread operator. So the spread operator is also very important, and this allows you to easily copy objects, merge objects together, and really just manipulate objects with ease while doing what are called like immutable state transformations. So one of the core concepts of React, and I'll get into this later in the presentation, but is that you want to never directly manipulate data structures. You want to always make a copy of them, and then you manipulate that copy. And so the spread operator makes it very easy. So you can see here, by just using the 3 dots, you can take an old object, copy it into a new object, and then you can reassign the value of something. So here I have a user, and I'm now making them an admin. But these two objects are distinct from each other. If you were to directly manipulate either one, they won't affect each other anymore. It's very convenient. You can also use it to just merge objects. So we do that here. We have two distinct objects, and we merge them together. And so now you'll have all of the top-level items here. You'll have first, last, and hobbies in one object. And then you can do the same thing with arrays. And so you have two arrays here. You can spread each array into it. And then here I can also inject an individual item in the middle of the array. It's very convenient for inserting stuff into the middle of a list, which is pretty common. And then we'll get into what all of this means in a little bit here, but the spread operator can also be used when you're writing your components. If you have a lot of properties on your objects, it can be a big pain to constantly be typing out name equals user.name, role equals user.role, et cetera. It's going to be a big pain to be typing that much, and so the spread operator makes it really easy. Another nifty feature of modern JavaScript is arrow functions. Arrow functions are a great piece of syntactic sugar. They work mostly the same as regular functions. There are a few caveats. I'll get into those. But basically, old style function, you just say function, your function name, and then you have your curly brackets here, and you return something. I snuck in a little Easter egg. This code might look unfamiliar to you. These are template strings. You should Google JavaScript template strings. They're very useful. So here you can see I take that same function and it's now one line. You have the arguments coming in, what's called a fat arrow here, and then an implicit return. So if you don't have curly braces around the body of your function, it is an implicit return, which saves on typing. But also these functions are all bound to the current scope, which is very, very useful in the JavaScript world. Have you ever been confused about what this is in JavaScript? This will help you. But if you do put curly braces around it, you do need to have an explicit return. And then if you want to return an object, which you're going to do often, you need to wrap the object in parentheses. The other cool thing that modern JavaScript has are classes. If you've written Java code, and I think a lot of you probably have written Java code, or at least seen it, we finally have classes in JavaScript. It's great. Historically, you could really only write complex objects using the prototypical inheritance model, which was basically the same thing as classes, but a lot more effort. And so now it's less effort to do the same thing. One of the other cool features that classes have, my favorite feature, I think, are getters. And so with a getter, you can create a function that maybe calls other functions or does some sort of processing on your data. But then when you use the object here, you actually just reference it as a regular attribute. So this is really great if you have a lot of computed properties on your objects, which you probably will if you're writing React code. The other feature of modern JavaScript, probably my favorite feature, is the new module system. So back in the day, again, a couple years ago, you would just import a script. Then you would have another script tag here that would have to come sometime after. This is actually a simplified example. You probably want to check that the library is on the page and retry, but you would use the library. Now what you do is you just import it, and then you use it, much like every other language out there. So next key feature of React is JSX. So JSX is a superset of JavaScript. And it lets you embed HTML and DOM elements directly in your code without having to put it in some sort of template string or anything like that. And it just makes your code a little bit easier to understand, especially since you're outputting DOM elements. So to see the DOM elements you're outputting while you're writing code is particularly useful. It is not natively supported by browsers, and it probably never will be, although don't quote me on that. But you do need to use something like Webpack or Rollup if you're going to use JSX. And if you're using React, you don't have to use JSX, but you probably want to be. So the next concept are components, right? So these are the little Lego bricks I was talking about. React ships with a bunch of components, but they're the ones you already know about. So they're the div, the H1, H2, et cetera. But you get to make your own. You can extend React component. You'll see some examples there. You'll see some examples in a second. But it's important to know that there are two types of components. There's functional components, and there are class-based components. So functional components are just functions. They are stateless, which I'll get into state management shortly, and they're pure. Well, they're supposed to be pure. What I mean by pure is you take input, right? You have your arguments to a function, and then you have a return, and there's no side effects. So if you're writing a functional component, or if you're really writing any component, you should never be manipulating the data structures passed into the function and changing them, because it will result in all kinds of weird, odd behavior, and it'll be very hard to debug your code. So make sure, if you are using functional components, that you are writing pure functions. And that's really the idea of pure functions is a very important concept in React, and you'll really want to get familiar with that. So the other type of components are class-based components. They are stateful or stateless, and they have all these different lifecycle methods that let you hook into how React works and they give you all kinds of benefits. I'm going to cover a few of the lifecycle methods in my talk, but there are a bunch I'm not going to cover. The React documentation is wonderful, and you should read it, and you should familiarize yourself with the lifecycle methods. But just know that they basically give you more control over your component, and they're very, very useful. So here's an example of a function component. I have a rectangle stats component. It's a bit of a contrived example, but slides can only fit so much code. My apologies. But what you see here is in this function component, we have a rectangle that's coming in from props. So a function component always takes one argument, it's props, and in that object you pass in various variables. And so you'll see that happens down here, right? So if we're using the rectangle stats component, you say rectangle equals my rectangle, right? So then in the function that you write, you have access to rectangle. So basically, you can see it just takes all the arguments passed via these attributes that look like HTML attributes. They get converted to a props object, and then you use destructuring and all the convenient stuff here. And this is why destructuring is very useful, is you're going to be dealing with a lot of objects. So to be able to rip the stuff out like this that you care about is very important. So the other important thing here, right, is you have to return some form of JSX, or at least another component or something like that. And so what you'll see here is we have these little curly braces here, and what that does is that says inside this curly brace you can put any JavaScript you want, So in this case, I'm just putting the width, height, and area. And what that does is just puts it in the DOM, right? And that renders it. But you could render a list of other components. You could render all kinds of stuff. So here is a class component. This is straight out of the React documentation. I did this because I wanted to show you a pretty good example of set state. So this is what I mean by stateful or stateless components. We have a state object that is created in your constructor here, and you initialize it to some value. And then here are your lifecycle methods. These are the ones I was talking about. So component did mount is a pretty important one. You're going to use this one all the time. There's another one called should component update. I've got that one on another slide I'll talk about. But in this case, what this means is once the component is in the DOM, right, it's being rendered to the browser and the user can see it, that's what this does. So once it's mounted, you can do something. So this is typically where you'd kick off some sort of AJAX request to load data or any sort of initial loading of something is typically what you'd use this in. Sometimes you might need to mount a third-party library, like maybe a jQuery component or something, and you don't have direct access to it. So you would want to do some magic here, and your component did mount, and then a component will unmount. You would clear your interval in this case, or maybe remove any event handlers you had attached to the DOM elements, or anything like that. And so that's just a pretty basic class component. So state management is extremely important in React. You're going to be writing a lot of stateful components, and you're going to be writing a lot of stateless components, but it's important to know that state management is probably the thing that people get wrong the most. It's pretty tricky, and the reason it's tricky is because you need to be making immutable state transformations, and I'll get into that a little bit later, but here are a few key tips to follow. So you always want to define and initialize your state in your constructor, like I did here. And when I say that, you want to define the entire data structure if possible. If there are some variables that you're just not going to have right now at time of instantiation, then I would still define them as something like undefined or null or some other useful something. You want to be able to, you want to be able to see all the potential states when in your constructor. It's very useful, and it's going to help you debug your component. You're not required to do that, but it is definitely a best practice. especially if you're writing a component and you're having some problem with some particular variable, it's not in the state you want it to be in, and then you realize, oh, hey, that's weird. We're appending these different variables in our state object later. It can be very confusing. So best practice is to define upfront your state object as best as possible in your constructor. So state is updated via a setState method, obviously, right? That seems pretty straightforward. What's not straightforward is there are two forms of setState, and this is where it gets pretty confusing. So there's the object form where you call this.setState in your component, and you pass in the new state variable you want to update. You don't need to pass in the entire state object. You can pass in just a partial update. So if you have 10 fields on an object and you only want to update one, you only need to include that one in your setState. The other version of it is a callback form. So that's the one where you have to pass in a function. That function will be called by React at some other time later. That function will pass in a state argument, which is the current state. It's the current source of truth. And if you need to be calculating some other value based on current state, this is the form you want to use. It's a very, very common bug where people will use the object form, and inside the object form, when they say this.setState, and you see count, you'd say, this.state.count plus 1 would be a bug here. In this form, because we have state, and this is definitely guaranteed to be the most current form of state, you want to use that to calculate it. Otherwise, you'll actually run into race conditions. And the reason that is because calls to setState are batched. So just because you're calling setState right now does not mean that the line after is going to have that current state. If you have several setState calls back to back to back, they will be batched together. And so you need to make sure that you're using the callback form. So the really awesome rule of thumb here is just don't use the object form. It's very easy. Always use the functional form. You can't mess that up. I really wish they would deprecate the object form of this and remove it. It causes a lot of confusion. It's bit me in the butt a few times. As you can tell, I'm a little bitter about it. So the other piece of information you need to know, and I've already mentioned this, is don't directly mutate data. No, don't do it. Don't do it. Copy an object first, manipulate the copy of the object. That's fine. Never manipulate your state object directly. Always, always, always off a copy. This is where the spread operator is your friend. If anything, it's your best friend. You should really learn the state operator, get familiar with it, and learn to love it. It's great. So,
the spread operator is at 3 dots.
The 3 dots, correct, yes. The spread operator is the 3 dots, yeah. So, a little bit more here. You're going to want to keep your state in an easy to manipulate format. And this is because you don't want to directly manipulate state. And the more complex and more deeply nested your state object gets, the harder it is to manipulate it, and the more you're going to want to just directly manipulate it, which is a big no-no. Don't do that. So you're going to want to prefer flat structures. There are several libraries out there that can help you with this. One of them is called Normalizer. I don't use it. I don't think you necessarily need to use something like that. But you just need to kind of think a little bit ahead of time of how to flatten your structure of data. And then maybe, let's say you have this flat structure data in your client, but you know the server requires some nested object. What I would do is right before you send that AJAX request, grab that current state value, transform it into the nested structure that you do need, and then send that to the server, and then basically just throw that copy away. You don't need it anymore. You have the flat structure still, right? And then the final tip, and I'm going to have some examples to kind of walk through all this, is to keep separate your state changes from your event handlers. So a very common thing when doing front-end development is reacting to user input or reacting to some other event, right? You'll put an event handler on a DOM element, maybe like a click handler or an on-change handler or something like that. And the best thing you can do for yourself is to separate all the cruft of handling that event from the state changes. So what I mean by that is you're going to be passed an event. You're going to want to typically call like prevent default and stop propagation and stuff like that. Do that in one function and have that callback handler call a state change operation. The reason you want to do this is it's going to make your code a lot easier to test, especially if you want to use some sort of unit testing framework like Jest, which I would highly recommend you do. This will make it extremely easy for you to test your code. It'll also make it a lot easier for you to debug your code. So here's a stateful component. This is the what I would call like the first pass. When I write a component, I'll probably do something like this, where you have your constructor, you've got a state with a value in it. This is what I was talking about with the change handler, right? You're gonna call stop propagation, prevent default, you're gonna rip the value out of your event, and then you're gonna call set state, and you're gonna change the value. And then down here, I have an input, I have my change handler, and then I have the current value of my state, so then I'm rendering that current value, right? And so this is fine, it works, it's a good component for the most part, but it's kind of hard to test. Now if I want to test this via some sort of unit testing framework or whatever, not only do I need to figure out what I want to change the state value to, but I need to actually go and mock up a whole event, which is kind of a pain in the butt. It leads to a lot of test code that's a little unnecessary, and in general, you don't want to do that. So here's what I would do. It's basically the same component. So what you have here is an update value function, and it just takes a value, and I call set state and value. This is a pretty contrived example. Normally, I wouldn't necessarily do this because I'm just calling set state of one variable. But in React, especially if you're writing some sort of form code or anything, I mean, anything you're doing in LabKey, you're probably going to have a somewhat complex data structure. So this example is, while contrived, I have limited space on my slides here, is going to be what you're going to want to do. You're going to want to have your state change functions separate from your event handlers, and then they just call it here, right? And so other than that, the component is basically the same thing. So the other thing you want to do, I've already mentioned this, but you're going to want to start loading state in component did mount. The gut instinct that I always had when I first started writing React was to do that in your constructor. Don't do that in your constructor. It's not the appropriate place for it. The appropriate place for it are the lifecycle methods, and then particular component did mount. So let's say you have some sort of component that maybe makes an AJAX request. I just wrote one recently. We use the Browse Data API to get all your reports, and then we kind of play with that data, and then we render it in a list. You want to kick off that data loading in component did mount. And then the other thing you're going to want to do, and this is a big one, this is going to be the thing that will probably help you the most when it comes to state management, is separate your components into stateful and stateless. I'll have an example, but the gist of it here is the final component to render everything should only be rendering stuff. It shouldn't know how to manipulate data. It shouldn't be touching your data. It shouldn't know how to load data, nothing like that. It might need to know what the data looks like so it can maybe do some light, changing of the structure or something so it can render it, but you don't want you don't want the final component rendering something to be too smart. And the reason you want to do this is, again, testing. You want to be able to easily test your components. So let me go ahead and show you an example. So here's the stateless component rendering the data, right? So I've got a to-do list here. This is a pretty common example. I have a loading prop, and so if the component's loading, I just return a simple div that says loading. And then if it's not loading, what we'll do is return a list. And then here, this is a good example of me using that JavaScript curly braces here. So in my to-do, it's a list, right? It's a to-do list. So what I do is I iterate over all of my to-dos, and I render a simple list item here. This key is important, but I don't have time to get into it right now. And then here I just render the to-do text, right? And so this component is really simple. It's only rendering. There's not a lot of logic in it. This is great. It's easy to test. It's especially easy to when I'm developing, right? So not even if I'm writing tests. So maybe you need to build a component. It needs to render your data in a certain particular way, but maybe you don't want to deal with all the fetching the API or whatever. Maybe the API takes a couple seconds to return. It can be a big pain to just sit there, make a code change, hit save, wait a few seconds. Oh, it didn't render right again. Okay, make another change, wait a few seconds. Oh, it still didn't render right. So what I would like to do when I'm developing is I'll write my stateless components first. I'll get that all set up, and then I'll just hard code an object at the top of the file that I want to render, and then I can sit there and just fiddle with my component, hit save, boom, instantly know whether or not I'm doing it right. Then once I nail all that down, I'll write the stateful component. So the stateful component will look something like this. Here I have a stateful to-do list, right? So I have my to-do list, and then I have my stateful to-do list. They both just extend React.component, nothing too special here. In the constructor, I set up my state. You'll see that I set to-dos to null immediately and loading to false. So now when I look at my constructor, I can see, hey, look, that's all the possible states that I have right there. Then I have a load data function. Again, I like to separate anything with loading or changing values away from the other lifecycle methods. Don't like to tightly couple those. And then in component did mount, I just call load data, very simple, very straightforward. And then the only thing this component renders is another component, that's it. Just renders to-do list. This is the stateless one here. I pass in the current state of to-dos and the current state of loading, and I let that component deal with all the logic for rendering. This is great. It makes it way easier to test our components. Typically with a component like this, you would want to test this against a real server, so this would probably be a Selenium test, whereas this component, the stateless one, is much easier to put into a unit test. And so this will be really, really helpful for you. And the unit testing frameworks are really, really great. You could do all this stuff without even having a browser and see what is rendered in your unit tests. Very, very useful. So the next important topic, and it's probably the second most important topic. I'd say state management and knowing how to manipulate objects and do that is really important. Reconciliation is also very important, and it's a complex topic, so I'm not gonna go too deep into it because there's a really, really great set of rules you can follow that will let you kind of avoid having to know the nitty-gritty details. But if you want to know the nitty-gritty details, this article is really great, Optimizing Performance. I would start here because it has a really, really great example and description of what reconciliation is. And then I would read the official reconciliation docs because the description there is actually, in my opinion, a little bit worse and less clear. But if you read this one first, this one will make way more sense. So these two resources are very important. And I have a wiki page with all this information, so don't worry about furiously writing down notes or anything right now. This will be easy to get access to. So what is reconciliation? Reconciliation is the algorithm that React uses to know whether or not it should render a component. So if you have a lot of components, it's effectively a tree of elements, right? Think of a web page, think of all the HTML elements on that page. If you change something at a high level, all your child components might need to re-render, but maybe they don't, right? Well, if you don't properly abide by the reconciliation rules, if you change something at a high level, it will re-render every DOM element on the page, which is just bad, because the user won't see any difference at all on most of the page. And if they're trying to do something like click a button or enter text in a field, what you'll see is really, really bad performance. So we actually we ran into this recently where we had a form that had about 10 elements on it, and it was fine. But once you got to like 15 inputs on it, a user would start typing on the page, and they wouldn't see their text in that field for a second or two, which is just really bad. And the reason was because we were rendering every single text input on the page every single time a single keystroke was entered. That's really bad. So, actually I have an example of that. So in this rectangle form, just taking a width and height, and it extends React.component. We have a form. Let's just assume that these are rendering all that boilerplate from earlier, right? And you have an input here, and you have input here. They both share an on-change handler, and they're just for the width and height. Because this is a React component, it doesn't have a method called should_component_update. And so what that means, so what it does by default is it just says, anytime that should_component_update is called, it updates the component. So it re-renders the component. So in this component right here, if everything here is just extending React.component, anytime a user updates width, every single DOM element on the page gets re-rendered. And in this contrived example with 2 inputs, you'd never notice. But like I said, if you get to like 10, maybe 15 inputs, you will notice. You will definitely notice, especially if any of your render functions are even slightly expensive. And so the trick to follow is using pure component. So React, all their documentation points you to component. Some of their documentation points you to pure component. The trick is very, very simple. Never use component. Always extend pure component. I would even not write functional components. I would always just use pure component. It's what I do. And you'll almost never run into performance issues outside of any other like related stuff. But if you use pure component, you will be A-okay for the most part. It'll get you 90% of the way. And then if you start having performance issues, then you'll go learn the other lifecycle methods. You'll figure out what should component update, how to write a good version of that, and you'll be fine, and you shouldn't have any performance woes. So always use pure component. It's demo time. So one of the cool things that you get with React and React development is a fancy build system with Webpack. And what Webpack gets you with your fancy build system is a really great development environment. So I know the code here is really small and you can't really see it, but I assure you it's not that important. So here's a little simple hello world page. In it I have a title that says hi, and then there's a little simple block of text here. And then you can see I have the developer console open, and there's some messages in here with HMR and WDS. Well, HMR is hot module reload. It's really cool. So what does that mean? Well, that means I have some components on the page, and if I want to change what they do, I can. So let's change the text here to hello world, because this is a hello world example. You go ahead and hit save. Boom, updated like that. Really, really useful. And then you can see I have a title component here. I could take another title and just kind of copy and paste it and hit save. And then maybe if I wanted to expand this into another component, maybe greeting. I should probably put a capital G on that though. I could kind of take the title and span here, and then return. Uh-oh, what did I do? Oh no.
You're missing this file.
Ah, thank you. All right. Pair programming at its best. So here you see I am destructuring an object. I've got greeting and description, and then I'll just pass greeting into my title component, and then I will just render description into that, and then I can remove this and change it to just be a greeting. Boom, done. So this is super, super useful. Another benefit you'll get with these, with a development environment like this, and I can't go into details because it would be like 3 other talks, is there are a bunch of great tools. So there is a profiler that you can get with newer versions of React. I don't have any inputs on the page, so I can't really profile anything, but you also get a special DOM viewer that can be particularly useful. So what you'll see is, typically if I inspect the page here, right, you'll see all of the HTML being generated by my application here, which is useful for debugging for sure, right? But maybe a certain block of HTML is a component, and you'd rather look at the component view. You can see a very similar DOM tree, and you'll see that it highlights it just like the regular debugging tools do. So it's a really great development environment. I really like the pace of being able to go into my editor, change code, hit save, not have to refresh the browser myself. It is wonderful. I really, really like it. And so that is basically it for the demo. The page I have set up, we can go back to presenting real quick. Yeah, okay, so yeah, that's basically it for the demo and my talk, I suppose. So in conclusion, React is very powerful, but it's deceptively simple. Make sure you read the documentation for React. Anytime you find yourself using a new lifecycle method or you're Googling around and someone suggests you do something, I would make sure you read the React documentation. It's actually particularly well done and well written. And just make sure you understand the ins and outs as best you can. Start simple, start small, and learn as you go. Reconciliation is very important. Definitely make sure you understand it, but luckily there's pure components, so you don't have to learn that right away. And just definitely be careful with state management. It's hard to get right. It can be it's easy to mess up. And basically just remember, copy first, manipulate the copy, done. And so this URL here at the bottom is a wiki page that has my slide deck attached to it. It also has a bunch of other resources I point to. There's TypeScript, React Router, Redux, Immutable, Jest, Enzyme, ESLint, Prettier, all that. It's all mentioned in that wiki. It's all other great topics you'll want to learn, but I just didn't have time to get into. So that's it. Questions?
Did you do a quick walkthrough of what else is in the demo module?
Oh, sure.
Just because I know folks are interested in how to kind of plug in the module build and all that.
Sure. So the demo module is called tutorial modules, and it's in the demo. The repo's tutorial modules, and the demo is in the demo folder here. It's like any other LabKey module. So what you'll do is you'll git clone it into your server modules directory. You'll add it to your Gradle build file, and it'll start being built. Then there's two key things to note here. You're going to need a node and npm installed. Gradle will install it for you, but you need to have it on the command line yourself as well if you want to be able to start the dev build. But once you build this, it'll work pretty well. Now there is a source folder, and in the client folder, this is the one you care about. There's a hello world page and a to-do list page. These are just two examples to go off of, and then these typings are for TypeScript. I would just avoid TypeScript for now. It's great. I recommend learning TypeScript, but start with just JavaScript and then pile on to TypeScript later. It's very easy to adapt to code base, so I would just go there. The page I was manipulating is the Hello World page. You'll see there's app TSX and dev TSX. These are the difference between the production build and the dev build, and then the component itself is here. It's very simple. And then we have a spec.tsx. This file is a unit test file, so we have an example of what unit tests look like. They're very useful. I would recommend taking a look at this. And then we have a SAS file in here, but you can also use CSS. And the cool thing about the modern build systems is you can import your CSS files in your components. So you can make sure you keep all your styles for a component in a, like, say you have foo component, you can have foo component.css and import that CSS file in your component. So you know it's there and the styles are associated with each other. It's pretty useful. And then you're going to need to read the documentation in the README here. If anything's confusing, let us know. We can update the documentation. But what you'll do is you'll need to be on the command line, and you'll need to know that you use this npm start command. If you run that, it starts a dev server, and that's what gets you this wonderful page. Does that answer your question?
Yeah, and then is there anything in particular you need to have in your module to have Gradle build kind of pick up and package it in the module? It may just be the default module build picks it up at this point.
The default module build should pick it up. That's my understanding. I wish Marty was in the room. He would.
Package, you want to show the package.json file?
Oh, yeah.
It's at the top of that is the build script. Those scripts are the important.
Yeah. So Gradle will pick up the module, and it should know to run these commands here. And so there's a bunch of commands here. The ones you'll be most familiar with as a developer would be the start command, and probably and hopefully the test command. Hopefully you're writing tests for your components. See a question in the back.
So, is there documentation on your Gradle package.json, your Gradle plugin, moment tag? Is there documentation on what the scripting should build versus build prod?
Corey, do you know that?
Documentation out there on what the scripting is expected to be?
I think a couple of them are
And setup, I think.
and setup. Can you say that when it looks for?
Yep.
Okay, yeah.
I've ran into that. Build mode dash build mode log. I'm just wondering if your documentation that you got.
Not here. We might have documentation elsewhere. What I'll do is I'll make note of that and I'll figure that out and I'll try and put it in that wiki page that's in my slide deck. And then if needed, maybe we'll update this repo as well.
If there's additional command restrictions you want to add beyond that, stop that as well. Yes, there are a couple of them. Ours is different, or we should document that.
If you don't want to just change your entire comment to React, you want to slow urgent.
Yeah.
Maybe component by component. What are some of your suggestions?
So interop between frameworks is possible. It's a little tricky. It could be basically a whole talk in its own. It depends on the situation exactly. What we recommend right now is not going like full single page app. And we recommend maybe writing a page at a time in React. If you need to have part of your page render some block of code and you want to swap out one part with React, when you write React code, I hope this will work. One second. Oh, man. Yeah. So to render a component, you call React DOM render. You pass in the component you want to render, and you tell it where to render. So you give it an element. And so you could have a page that renders X here or even jQuery here or whatever. As long as you keep the React code completely separate DOM-wise on the page, React won't know. It only touches the element that you tell it to point to and everything below it. So don't render something here and then have a jQuery component touch the React stuff. That won't be good. If you need to do that, there are ways to do it, and it's pretty well documented in the React documentation. But yeah, but basically, if you are able to completely separate like from a DOM element perspective, does that make sense? Yeah.
In your component examples, sort of middle of the talk, it looks to me like you're using the object form of set state. Is that correct?
And sorry, was.
So you had some component examples kind of in the middle of the talk.
Yeah. And so that's just because it's less lines of code. So the question was, I was using the object form of set state in my examples. I was also, if you notice, I was using component everywhere. The reason I did that is because that's what all the React documentation does. I didn't want to kind of overload people with too much information. The object form of set state isn't inherently bad. It's just that you can mess that one up. You are way more hard-pressed to mess up the function version of it. But basically, if you know, you can follow a quick rule of thumb, which is, if you know you're not going to compute state based on the current state of things, then you can use the object form just fine, no big deal. But if you need to reference current state, so that if you have like a counter, or if you're gonna append to a list of things, or whatever it may be, then you need to use the function form of it, yep. And so, you gotta know that rule, but I would just always use the function form if you can. Any other questions? All right, one more, I think we have time for one more, yeah.
So in your to-do list example where you had a functional component of graph, you're storing state loading and stuff in the graph component. Where do you handle others?
Okay, great question, great question. Let's go to the example real quick. Where did it go?
Can you repeat the question?
Yep. Okay, so the question was, I've got two components. I'm splitting the rendering and I'm splitting all the state management and other logic, right? Where do I do the state? Where do I do the event handling bits of code? What I like to do personally is in the stateful component, this one, it shouldn't know about browser events. It should only know how to manipulate data. And then in your stateless component, that's where I would have the object handlers that know about browser events, isolate those, and then just call a prop. So what I would do is I would pass a prop into, so I have the stateful component here. I would create a, like instead of load data, I would have like update data, right? And I would pass the update data function into the child component as a prop. And then in the stateless component, handle all the event details, the browser event details, stop the propagation, all that, separate that logic, and call that update data function, right? It's basically the same rules apply, but where I would put the actual raw event handler stuff in the stateless component. And then the data manipulation logic should go in your stateful component.
Or more. And,
Sure.
I'm happy to speak to this if you don't want to be
Sure.
on the spot, but I think it'd be useful to share kind of our general plan for sharing the class component.
Sure.
And, JavaScript API, the package-based
Sure.
version, because I know folks are interested in not just how to do React from scratch in LabKey,
Sure.
but how they can leverage things that
Yep.
we're building.
So a good example of how we're using React at LabKey is it's biologics and sample management are largely written in them. Biologics and sample management, as you've probably all seen, look and feel very similar. And that's because we have a shared component library that we've been creating in-house. It's going to be part of the community edition. Right now, we're in the very early stages of writing this shared component library. I would say even pre-alpha, but the code's there, and we're building these components up. And the hope is we'll have some components that would be particularly useful to be used, something like like data regions or grids. Everyone knows those. We render them everywhere. I'm assuming all of you kind of live and die by the grids, right? Stuff like that would be pretty useful to have and be reusable because they can be pretty complex. And so the plan is we'll have sets of components that can be used, and we'll have a separate NPM package that is versioned, and we'll be updating that and adding features to it. And you should be able to add it as a dependency to your builds, and then get access to those components and use them while building your pages. Is that, you want to add to that, or? Right, great.
That's good. And yeah, if you have a lot of questions, here is room for kind of smaller follow-up.
Yeah, and if you have more in-depth questions, I'm here all day, so just find me. I think, is that it? If we've got time. Okay, great, yeah, sure.
So we looked into it, and you mentioned that in React you can bring external other components from other libraries.
Yep.
You mentioned jQuery, I think was the one.
I wouldn't, yes, okay, so is that,
No, the reason that I'm asking is that, so in our site, our university, their UI team is pushing Google Materials.
oh, sure, yeah, okay.
And we looked a little into it, it was not really clear that, why would we use another set of components if React had its own components?
Yep,
But I was just looking at the
Yep.
website, and it seems like it's now
Yep.
more possible.
oh, it's completely possible. So the question is, I mentioned being able to use a component library and from a third party, could I use any other component library I want to use? And the answer is yes, right? Because we have that package.json and we know how to build it and we know how to put on those dependencies, you could list something like, this is a very good example, Material UI. You could use this as a dependency and you could make your entire application that's built on top of LabKey look like a Material UI app if you wanted to. These libraries, I would do a lot of research. There are a lot of component libraries out there. Some of them are better maintained than others. Some of them are really actively maintained, but still not well maintained, I would say. And what I mean by that is they're always changing and they're always breaking their APIs. So be careful, kind of take a look and pay attention because you might choose a library and then get stuck with it for a while because it's a huge pain to upgrade. That's a common pain in the JavaScript world just in general. And so be careful, but I'd say believe this Material UI is very popular and well supported. There are other ones that look like completely different but still have a really cool look and feel. So yeah, Google around, take a look. There's plenty of third-party libraries out there. The JavaScript ecosystem is huge. Yeah. All right, I think that's the last question. Sweet.